Thank you very much for having me today. I appreciate the opportunity to get out of Tucson. This is actually my first time on the U of A campus. I've only seen it from Speedway. I have not realized what a beautiful campus it is relative to the ASU Sun Devil campus. So you certainly deserve kudos for that. As you heard, I'm senior civil engineer with the city of Glendale. I was brought into the pervious realm probably about 8 or 9 years ago because of my materials background in working with Jacobs Engineering and developing the pervious lot. Today I'm just going to touch on a few different things before I get more into the project related stuff. Low impact design is the same concept as green infrastructure down here in Tucson. They're called different terminologies, probably regional applications. There's probably a way to meld them both. Maybe low impact green infrastructure would suit people's thought process that don't deal with it all the time. I mean, it's conceptually just a way to, as engineers and public representatives, to build infrastructure that serves the public better overall, certainly that we heard in this morning's first presentation. There's a lot of benefits that come from stormwater. You can see stormwater, as we all know, is just what falls out of the sky. According to the MPDES and EPA quantifications, that's all it is the rainwater. As it hits the ground, it starts picking up constituents along the way. Rainwater in and of itself is not harmful, other than what it picks up as a result of the evaporation process, but where we run into problems is what it picks up along the way. What it picks up from undeveloped lots, what it picks up from curb and gutters, what it picks up from streets, stormwater systems, etc. As you can see with the natural groundwater, you have very little runoff. Development is what impacts this number. So the 10% runoff goes up quite a bit as your impervious surfaces do. Impervious surfaces are sidewalks, curb gutter, pavements, roofs, private development, anything that keeps the rain from getting directly into the ground. Larger impervious surfaces increase the amount of runoff, and when you get in 75 to 100% impervious, you can see the runoff generated goes up quite a bit. I won't spend too much time on this slide, but how much water do you usually talk about? As engineers, we like to look at the volumes of water. This is an equation we use within the city of Glendale to calculate a development that comes in, wants to put a building on an acre of property. How much roof are you going to have? How much parking lot are you going to have? Where is the water not going to be able to infiltrate into the ground? This is a big number you'll hear about as you get into meetings with engineers and developers. This says 95% of the water that hits a pavement is going to run right off. So for our park and ride facilities, at a 100-year event, which is our design standard, there's 240,000 gallons of water that come out of that event. If we have an impervious surface such as asphalt, all of that 240,000 gallons is going to run off the lot. Cities are responsible to retain the stormwater as well. We just don't require it as private developers. We require it of projects we build internally. And one of the most expensive part of land development is the land. So what pervious concrete enables you to do is capture the stormwater that you're required to do by the ordinance and not take up your footprint or your property basins to be able to do it. So basins use a valuable component of what the investment is. Why not eliminate them? And what can we do with all that water? The low impact design or the green infrastructure approach is you want to manage that stormwater. It used to just be let go, looked as a byproduct or an undesirable quantity. And as you realize, the philosophy is changing that we can use this stormwater. We can use it to water plants. We can use it to go in through swales. We can provide vegetation and retention basins, and we can capture it off of the roadway and use it to water the plants adjacent to it. But what we want to do is we want to treat it before it leaves the site. We want to minimize the impervious, pass through stormwater. So we want to use stormwater as a resource rather than a byproduct, if you will. one of the things that drives low impact design from a municipality standpoint is the NPDES permit that most large cities, smaller cities coming under the umbrella now is the NPDES, National Pollution Discharge Elimination System. This is a mandate by the federal government. All cities have to have an NPDES permit to control their stormwater. And it's this program that requires LID and green infrastructure that cities start implementing these policies and procedures. So in the Southwest, we still, because we don't get a lot of rainfall, which is where the park and ride comes into play, a lot of this vegetation can't be serviced only by stormwater. We still have to have additional water sources, irrigation, to supplement the summers and such where we don't get a lot of rainfall. A couple surface types that we're all familiar with, flexible pavements such as asphalt. It's much cheaper than concrete. A lot of not interstate highways, but state highways and some interstate highways are done with hot mix asphalt. We are starting to use more surface type treatments in parking areas and such. We have Portland cement concrete pavement that is most of the interstate system within large regional urban areas such as Tucson, Phoenix. You'll notice all of the interstates are done in concrete. It's high cost, but it's long durability. The last thing we have is, like I said, surface treatments we use. These are emulsions, pine tar emulsions. That's another way to get a drivable and stripeable surface. This is actually a lot in Glendale up at the Thunderbird Conservation Park, where we actually mixed an emulsion with a decomposed granite, get a drivable surface. It's about the same price as asphalt, but for a conservation park, we didn't want to just paint everything black. Sheet flows that come off of these three types of surface lead to higher flows. When I showed the earlier slide of the amount of stormwater leaving a site, it goes up dramatically because of the imperviousness, and all of this water as it leaves the site, as I referenced the NPDES permit, gets into waters of the U.S. So we see all these rivers around Phoenix, Tucson, and in the arid Southwest. Whether there's water in them or not, those are all considered waters of the U.S. Same down in Mexico. They might not have water in them all the time, but eventually the storm water is going to pass through sites and get to those areas. So what are some options to do to try to get rid of the concrete pavement or the asphalt pavement? There's a lot of products out there. There's geopavers. There is geogrids that enable vehicles to park on them. There's paving blocks we've all seen, and there's also open lattice paving blocks. What these do is these allow the stormwater, unlike Portland cement concrete pavement or asphalt, actually allows it to get through and capture some of that stormwater and actually use it as an attribute. They also reduce the heat island effect that we've all heard about. I'll have a slide a bit later from project down in, or up in Phoenix, I should say. So a couple other things we can do other than some geogrids and some paving blocks is pervious concrete. Pervious asphalt is used, but not in Arizona, not in the arid Southwest. It was tried once in Phoenix and promptly fell apart because it's too hot to support the traffic loads and such. It gets very viscous when you get those kind of temperatures. This is a pervious asphalt lot taken from the Midwest. You can see stormwater is captured here and flows off here. So it's a big difference between the two. And this is what pervious concrete looks like in a core and next to standard concrete. Actually looks a lot like a Rice Krispie treat. Another analogy I heard this morning in a discussion was, or a rice cake. It has that look that allows the water to actually run through the matrix, captures oil, captures everything because it doesn't flow off the site. So we started looking at it as a result of a consultant we hired for the park and ride. The original concept was a hot mix asphalt. So it's cheap, it's easy, it's quick, pave it, put some AB down, throw some standard canopy shades up, and we're done. Our council saw an opportunity to start looking at some other technologies back in 2003, 2004. They had looked at some of the components I discussed earlier, like gravel pave, grass pave, geogrids, pavers, et cetera, et cetera. We opted not to go with those because of traffic implications. You've got people that are parking at the facility, walking across, getting onto buses, and being bused to work. So you want to make sure it's a friendly surface for that. We also upgraded the shade canopies, and through those discussions, we had ended up, the city council had provided direction to use pervious concrete. Like I said, it was presented by Jacobs Engineering, who was our consultant at the time. And I met for the first time Dr. Kalush out at ASU, who turned out to be a very, very valuable resource through this whole process. I still sit on that conference committee out at ASU where I see him often. He is very helpful in any conversations I have, and I think all of us in this room as professionals, as we start getting pulled in these different directions of trying to use all these technologies, and it can seem overwhelming. But I think most of us, and Dr. Kalush certainly involved in that, are more than willing to pick up a phone, answer an email, and through those dialogue and conversations with him, I was able to come up to speed very quickly. And I think we're all willing to share that knowledge. You just have to be asked. So in the course of our day-to-day duties, that thought process has served me very well in my career. Why reinvent the wheel when there's people around you that are willing to help with it? Some of the attributes of the pervious concrete that we chose, one of the pitfalls of it, it's not structurally sufficient to carry heavy loadings. You'll see in the presentations as we constructed it, it's only in the parking aisles. It's not where the buses drive. It's not where the trash trucks drive, because it can't support the loading. So it's got benefits. It also has limited uses, certainly in terms of the traffic it'll carry. It also mitigates the heat island effect. This is a similar type product taken in north of Fountain Hills, and you can see the light areas at night. This was all the pervious or the white concrete here, and this is the hot mixed asphalt taken at night and during the day. So you can see the difference, how this allows the heat to release, this hangs onto it at night, which leads to the heat island effect. The other big benefit of pervious is the oil content. As we get parked cars at a park and ride, everybody's car drips eventually, and you'll see puddles of oil everywhere that are mitigated through the pervious concrete by virtue of it falling onto the surface, working through the matrix, being exposed to the air and bacteria and such, that it actually eat the harmful elements of the oil. Eventually, when it gets out the bottom of it and either goes into the groundwater table, works its way down, or is diverted into a catch basin, the oil is in essence pretty much been cleaned out of it. The park and ride facility that we'll talk about today, I'm not sure who's been at the Cardinal Stadium. It sits right here. Here's the Loop 101 freeway in Glendale Avenue. The facility is actually right here. You can see we developed half of it. It's about 390 spaces built out. This is for future expansion, these two lots. Currently there is asphalt millings on them to minimize the runoff, keep the dust down, et cetera, et cetera. But relative to the Cardinal Stadium, that's where this facility sits. Biggest thing we worry about as engineers is the cost. So it's much more expensive initially than hot mix asphalt, but over the life cycle of the product, it's actually a little bit less than hot mix asphalt. Makes more sense to do for all the reasons we've discussed: eliminate imperviousness, clean up oil, et cetera, et cetera. The other big concern as engineers, more of the engineering end of it, is how's it going to work? I mean, we all see technologies that come out and try to get utilized, always hear nightmare cases, but as an engineer, the first thing I thought of here in Arizona or northern Mexico in this region, we get very little rain. Big dust storms, very little rain. The whole thought process of this pervious is to have a matrix of stones to allow the stormwater to get through. It doesn't do us any good if they eventually plug up with dust and such. Another concern we had was there's no water in the mix, or very minimal amount of water. It's unlike regular concrete that you see driving to work or driving down the street. It's still delivered the same way, but in concrete there's a large amount of water, and you're able to chill that water before you put it into the mix, which brings the mix temperature down, which you don't want that cure process to start too early. Pervious doesn't have that ability. There's very little water in that mix. So we were worried about when we would be placing it. We were worried about increased maintenance costs, product we hadn't dealt with. We have a streets department that never deals with it. did not know if they would be able to handle or know what to expect as issues arise. And then we had questions on, okay, we put it on the ground, everything looks great. What does it do subsurface? What happens to the water as it gets through? As engineers, we're taught to get water away from our infrastructure as fast as possible because it's bad for roadways. That's the whole point of getting it away from the roadway in a gutter and sending it down the way, because you'll limit the durability of asphalt or concrete pavements. You want to keep those dry underneath. Some more thinking. I won't get a lot into these, but these were some of the things we ran into. One of the big things is temperature. Concrete can't get over 90 degrees before it's placed. It's what we've learned over the last 100 years. It's detrimental to the ability of the concrete to set up. We had to increase this to 95, knowing that there's very little water in the mix to be able to keep that temperature down. And then we had questions on how do you test it? I mean, I've been dealing with materials for the last 35 years, 30 years, and it's always how do you test it? You can put it down, how do you test it? Pervious has a lot of non-conventional ways to take a look at it. So as I said, there's very little water to keep the temperature cool. When is the worst time to start placing it? In August. So when did the project schedule work out that we started placing it? The time when we didn't want to. We started placing it in August in 2007. All of the placements went at night because we knew temperature was a concern and we had no control over it and couldn't control the temperature of the mix with the water introduced to it. So our placement continued from when we began in August, probably through the end of October, maybe early November. These are some pictures. You can see it's delivered in a ready-mix concrete truck. This is actually a lot out at ASU. This is a site that we visited before we started looking into our project. Dr. Kalush was doing this lot at the ASU Arts parking lot on the ASU campus right off of Mill Avenue. So it's placed with a ready-mix truck. It's not really compacted. It's more leveled with a rotating screed. This does not vibrate. And you can see these guys just pull on it. It's rotating the opposite direction of the pull, and it just smooths the surface. Afterwards, they cut joints in it with what looks like a pizza wheel. Literally, that's probably about a 40-pound pizza wheel. They just travel it to and fro and give an expansion joint. There's no conventional expansion joints as engineers that we're always used to. And then as soon as that material gets placed, it has to get covered. Certainly because of August or because of the time, the concrete or the cement and the concrete inside the cement inside of it needs time to hydrate. If it dries out, you won't get any compressive strength. So everything has to be sealed with plastic to allow it to cure properly. And you can see from the Arts College, you can even add coloring to it. They had a couple areas where they were trying a few different things. That was the first placement by ASU. They added color to the mix, which is always an option. Construction continued. We had a lot of canopy installation. We had heavy equipment on the mat itself. You can see they're fancy canopies, if you will. Well, these had to all be brought in by forklift, pneumatic forklifts. That was a concern of ours. We're imposing heavy wheel loads on it. It did not turn out to be an issue. Here's an area you can see. This is the dry bus aisle right here. You can see this is during a rain event. There's no water at all ponding here, and everything ponding on the concrete. So that's once again, what it's meant to do is capture everything and send it straight through the matrix. Here we've got the canopies going in. You can see panels curing. These are bio swales, if you will, that were planted. And this is the area at night, the area before the canopies went on. Interesting story. I mean, all these lights were designed to place up, but they hadn't thought about the rainwater coming off the roof, which promptly filled all of these light canisters with water. So can't catch everything. They had to come back and redesign a water seal. So there's other things, as we all know, that come up in projects that people generally don't anticipate. This is the bus drive aisle here before it went in. Buses come in, pick up people at one area, and then they leave the site through here. So once again, it won't support those heavy wheel loads. But what the biggest component, like I said, is it captures stormwater, cleans it, and stores it or sends it on its way. This is a quick map. I was so worried about the new product, and I had never used it. Now that I visit it every 2 to 4 years, if I see things in the pavement, I can pull up the exact records from the exact truck and look at the mix that the plant sent out to the site to see if we start developing any problems, is there a way to trace them back to the materials? Like I said, it's great to build this stuff and everybody walks away. Well, if you start having trouble in 5 to 7 to 10 years, you miss an opportunity to look back and try to figure out what happened if you don't keep these kind of records. So this is a quick technical stream, or screen, I should say. Average strength, or about what you would expect in a low strength concrete, 2100 PSI, unit weights, temperature, only one load. Our specifications allowed a load to be rejected if it was greater than 95 degrees. We only rejected one load in 2.5 months of placement, which is pretty good. And I think that lends itself to placing at night. Stockpiles were pre-wet at the plant to try to get those temperatures down. And the reason it drains so well, you can see the amount of voids in the structure. There's 27% voids in that structure. That can draw on the magnitude. It will take about 700 inches of rain an hour. So water will run right through it as fast as you can put on it. I've seen 5,000-gallon water trucks full open onto the pavement. It might flow 4 feet to get away, but everything disappears directly through that pavement. Thicknesses, we had a little bit deficient thicknesses. We were able to monitor that and try to figure out what the issues were. Well, all this placement and field data is wonderful. Does it work? Did it actually work for us? You'll see these next series of slides as I visit the site. Here's what it looks like 2 years, a little over 2 years old. I had a little bit of the joints opening up, very minimal at best, which was expected. Was not nearly what I thought it was. After 2 years, we had some panels that cracked more than others right through here. We had a contractor that was beyond his warranty. Usually we used to require a 1-year warranty. Now we require a 2-year warranty. So if anything happens, contractor comes back in and fixes it for free and brings it back up to specs. Well, this contractor was outside of his warranty. Could have said, sorry, you're on your own, you're outside my warranty. They were very good. We were very fortunate in the contractor that we hired. Mike Riggs, who was with Progressive at the time, showed up with way too many people and came in guns blazing, wanted this project to be a success. So he came in a little bit over 2 years and replaced those panels, jackhammered it out, had to reorder mix that plant hadn't made in 2 years, and we reinstalled those. Got a little bit of differential settlement. You'll see these are 2 pennies laying adjacent to each other. They were off by each about 1/4 of an inch between the two. It was only one area. So I haven't looked at it to see why it was. Might have been thermal related, might have been expansion related. Didn't get any cracking adjacent to it. Had a little bit of grinding done on it because I didn't want a trip hazard 2 years after it. So the contractor came in and ground down this one area. And you can see we started getting oil on it through the vehicles parking. It holds, like I said, about almost 400 vehicles. And I had one corner in particular that had snapped off, the contractor had glued on at construction. And I kept telling him, it's never gonna work, saw cut it, do the panel, and this is how it sat 2 years after it. Let's move up to 5 years. You can see we're getting a lot more oil. Facilities actually being used, which is wonderful. That's what it was there for. We're getting a minimal amount of surface spalling, which was anticipated in working with Dr. Kalush. That is one of the things. You get some pebbles that come up. It has been minimal at best. There's the crack 5 years out. Had the keys out. It's still in place. Has never been repaired. I get a few cracks through it, which are expected. I mean, you can't keep anything from cracking forever. This was an area we were worried about thickness in construction. So we had the contractor come in. This was at construction, which would have been about 4.5 years earlier. Saw cut a section out, verify thickness, and then we had him run some testing on this. Here's the saw cut lines. I wanted to keep an eye on this because I was wondering, is that going to crack, chasing a weak point in the matrix right here? Hasn't done anything from the time we saw cut it. And then I'm getting a little bit of debris because of the landscaping. You want to keep fine gravels for landscaping away from the adjacent area to this for fear it might fill in the surface voids. So you can see it's getting used, 5 years into it. Now let's move to last month, 86 months into it, which is over 7 years. Here's one of those other areas. Once again, no cracks chasing it. This product is restriped. We have handicap underneath the awnings. In addition to regular parking, I'm getting a little bit of the surface raveling just at the joint, which I anticipated, and more oil. Couple cracks, few surface cracks, nothing crazy, nothing opening up. So, I mean, for 7 years, we'll get into a slide on what they're doing to maintain it, but nothing to fix the surface. So what did we expect at the start of it, or what certainly did I expect? Surface falling, got some of that, minimal at best. Crack propagation, I think, has been to a minimum. The cracks I had to look for. There aren't a lot in this area. It's about 3 acres. Got differential settlement. The only area I saw was what I had showed in the picture with the 2 pennies that were separated. Getting a little bit of joint expansion where those joints are probably 1/8 of an inch, and not all of them, just in certain areas. And I was worried about the void structure. Will it still drain what it's supposed to now that it's 8 years old? A couple maintenance items. Our transportation is who owns the lot. It was their funding that paid for it. They flush it 4 times a year. They'll get somebody in there with the water truck, park it in the heavy traffic area, and actually flush the area down. Try to wash whatever might be in that void matrix down through it. We have a contractor inspects joints for crack, debris. I'm always out there. I'm always out there during rain events. Try to be out there during rain events. And this is a maintenance that we followed for about the last 8 years. And then Mike Riggs with Progressive, he had called me in March of 2012. Apparently the Chinese had a very large highway they were doing impervious. He had a small vacuum truck that he wanted to come out and do a few test runs on our facility. This is before and after. This is after he made his first pass. We ran permeability tests, where in essence is exactly what you would think. You measure the volume of water and the time introduced and how fast does it drain. You can see this is a before and after. Even after 8 years in these few areas, these will still drain 53 inches of rain in an hour, which is 8 times what we would see in an average year. And by him vacuuming it, he was able to get it up 70% over what it was. 5% in this area, 16 in this. This is some of the debris. This was a new machine that they were trying to sell to the Chinese government for maintenance of their freeways. So with it being a large facility that's being used all the time, there's a lot of opportunities for visits, research, et cetera, et cetera. You'll see these are quickly through this. These are some of the bad things in stormwater, and they're all picked up as a result of the water hitting the ground, which isn't a problem, but the minute it runs is where you have issues. Pick up a lot of sediment. You'll see pervious can remove most of everything that's there. Dry wells, basins, retention basins don't remove as much. Dry basin, you see everything has lower numbers to it other than the pervious because it captures everything and treats it. Some other projects in Arizona, ASU, as I said, did the the art complex parking lot. NAU, I think it was Dr. Chi I've spoke with a couple times. They did one up at NAU that fell apart. And he attributes that, as you would think, to the freeze-thaw cycle. Flagstaff has one of the worst freeze-thaw cycles in the country. Gets cold at night, gets warm during the day. It happens night after night after night, so the ice gets in there and actually cracks everything. They've actually paved over that lot and are reevaluating how to redo the mix and reinstall the lot in a different area to try to accommodate freeze-thaw, because he sees the benefit of not giving up and seeing if it's something that they can mitigate. Our park and ride facility, super light block facility in Phoenix, they had done all of their storage yards. I've got other pictures with 5 pallets of concrete block. This is a manufacturer, and their heavy forklift, they store all of their product before it gets loaded onto semis and goes out on that pervious pavement. And then the Phoenix Cement Terminal. Some good references for all of you. Once again, Dr. Kalush was fabulous through the whole process. I still talk to him all the time on this and other other materials type issues. Ken Ricker with RAM Engineering helped us develop the specs. Mike Riggs with Progressive. There is a YouTube video in this wonderful world of technology. You can watch the placement from the comfort of your own desk. Just go to YouTube and search Pervious, and you'll be able to see installations, examples, permeability tests, et cetera, et cetera. ASU, Joby, I think, Joby Phillips did a white paper I have as part of ASU's effort, developed a lot of stuff on Pervious as Dr. Kalush was getting into it. So there's a lot of very good documentation. Nationwide, certainly, but here for the Southwest is what impacts all of us. I've talked to engineers in Oregon, Washington State, Atlanta. I mean, all of those areas that work so well because they get a lot of rain. We have a unique opportunity to use it here because we don't get a lot of rain. So a few final closing comments. Has it worked? I think it's exceeded all of our expectations internally. Certainly mine with my materials background as an engineer, it's held up much, much better to this point than I would have ever anticipated. Maintenance is ongoing, but you have that with any surface treatment. Use is about 70 or 80% during the day, and it's been so successful. We're doing a new park and ride on the north side of the city. We're looking at using Pervious up there as well. It'll provide an additional benefit as it would in Tucson or in Mexico in that that park and ride is adjacent to the New River. So one end of the property will be bordered by the New River. So we've got to worry about it. If we put an impervious surface, where does that water go? Well, it has the propensity or could have the propensity to go right into the river bottom. So worked so well for us, we're looking at using it again. LID, the private industry, it's being integrated, but we can use it for retention, as I said, so maybe we'll require it at some point. And then curb cuts, some of the things you've discussed that can work along well with it, curb cuts, swales. One of the things we have to do that impacts everyone for all of these concepts is as engineers, we all say, that's great to put it in, but what happens when everybody walks away? One of the things that comes up with all of these types of things is who's going to inspect it further down the road? I mean, all of these items have to be maintained. So I think in ordinances or codes, et cetera, that if we start doing more and more of these cuts and swales that enter private property, sometimes you don't have enough area in the right of way, the property owner might or might not maintain it. So maintenance, not only the pervious, but everything we're talking about, you can't just build it and walk away. Somebody has to go back and take a look at it. So other than that, that's all I had for today. Thank you very much for your time. And one kudos to everyone down in Tucson is through all the committees I sit on up north, Tucson is always held as an exemplary area to look at in terms of what LID or green infrastructure processes they have in place. It's the first thing that's generally said is, well, how is Tucson doing it? So you all deserve credit for having the rest of the state and probably the Southwest look at what policies you're instituting to accomplish it in this area. So thank you very much.